Hi everybody. In this video, we're going to talk about 13.2.1, finding the slope of a line. Note, this is on here too, we are doing this topic in a different order than what's listed on EdReady. So meaning that when you're getting ready to click on the topics to do the practice problems, the first one that shows up is coordinate plane. And then right below that is graphing linear equations. Skip that one because we're not going to do that one right now. Because next we're going to do finding the slope of a line, and then we're going to do writing the equation of a line, and then we're going to do graphing. So make sure you're just paying attention to the title so you don't do a topic in EdReady out of order. All right, so definition of a slope, it's going to be used to describe the steepness and direction of a line. So steepness and direction of a line. So think about that. So slope is like your rate of change, and we're going to talk about some of those definitions. It's also your change in your y over your change in your x. So it's talking about like our steepness of our line, like what is our rate of change, and it's also talking about the direction. So these are all different levels of steepness, like if I'm talking about A to B to C, and like which one has the largest rate of change. Well, the greatest rate of change would be on B, right? So it's increasing the most amount in the shortest amount of time. So B would have the greatest rate of change. And then we're talking about direction, right? So another way to do direction would be like negative slope. So that would be a negative slope. This would be a negative slope. And we're going to talk about that here in just a second too. But I just wanted to throw up some lines just to kind of show you. So that's what we're going to fill in for our next point. So it's going to be the rate of change between the x values and the y values, and it's represented by the letter M. So M, we've got a couple different ways we can calculate change. So sometimes you're going to see it like this, where it's like y2 minus y1 all over x2 minus x1. You can also write it the other way around. You can write it as y1 minus y2. But then if you lead with the y1, you also have to lead with the x1. So it's going to be x1 minus x2. And I don't know if you recall this or not, but let's say you've got two ordered pairs, and the task is being given to you to go and calculate the slope between those 2 points. And so maybe you've got something like that. Well, this is just telling you like you're going to have directions that'll just say, just name the points, like name them x1, y1, x2, y2. And it's totally arbitrary for which one is x1, y1, and which one is x2, y2. It just doesn't matter. So anyway, when you're asked to calculate slope, this is usually the one that you're going to use, the formula you're going to use, or the one I'm going to give you next for calculating slope between two ordered pairs. And again, these here are called ordered pairs, in case you were wondering what that term meant. So the next one I like to give is change in y over change in x. And again, this is just a delta symbol, so it's your Greek letter delta, and it just means change in. And so you can almost think of it in terms of like an arithmetic operation of a difference. You're finding the difference between those 2 points, or you're subtracting them. So this next one, another way to calculate it is to look at the rise over the run. And oftentimes we're looking at rise over run on a graph. So like if I give you a line like this and I say calculate the slope between 2 points, you would identify 2 points on that line and you would calculate the rise over the run. And we would just end up finding it, like we'd find that change. So here's your rise, which is going to be change in y over change in x. You're changing your x value. So that would be a rise over your run. And then finally, another way to think about it is it's your vertical change over your horizontal change. So those are all different ways to think about your slope. So we've got 4 different types of slope. One, we've got a positive slope. So a positive slope is a graph of a line with a positive slope. It slants upward right. So positive slope is going to be looking kind of like that on your graph. And I like for you to think about reading the slope of your line from left to right. And so like take your finger from left to right and you're going, take it across the page and you're going to go like this with your finger and then you hit that slope and then you're going up the hill, like you're just continuing on up the hill. And so sometimes I've had students who just forget which one's positive, which one's negative, which one's 0, which one's undefined. Well, if you take your finger just like that across the page and then you hit the line and then you're like, okay, it's going up and to the right. I'm climbing the hill. I'm going up the mountain. It's a positive grade. It's a positive slope. So you're going up. So then the next one, of course, we've got a negative slope. So it's a graph of a line with the negative slopes, slopes downward and to the right. Downward right. So then like this one, we would have kind of going like this, right? So again, this goes back to where some students are like, well, it's going up as well, right? Because I see the arrow and it's going this way and it's going up. This is what I'm going to tell you. Take your finger again, going from left to right across your page. You hit that line and then you start going down. And so our person reading the grid from left to right is going down the hill, so it's going to be a negative slope. So in our equation, it would be like y equals negative 3x plus 2, something like that. So we'd have a negative slope. So then our next type of slope, it's going to be a 0 slope. And it's going to be a graph of a horizontal line is a 0 slope. And that should make sense, right? So think about like a person walking along this and so like if you hop on a treadmill and you're wanting to climb up the hill, you're going to change your slope to positive, right? Some fancier treadmills, you can actually change it to a negative grade and then you're going down the hill. Well, if you hop on the treadmill and you're not moving it up, you're not changing the elevation up or down, you're just going flat, you're straight. It's a 0 slope. Well, that is exactly what's happening here. It's a 0 slope. And then think about what your slope is again. It's your change in your y over your change in your x, or it's your vertical change over your horizontal change. Well, look at this. If I pick 2 points on this line, what's my vertical change between those 2 points? Nothing. There is no change, right? It's 0. What's my horizontal change between those points? Well, on this one, it's 1, 2, 3, 4, 5, 6, right? Did I count that one right? 1, 2, 3, 4, 5, 6. So it'd be 0 over 6, and 0 over 6 is 0. And so that's why it's a 0 slope. Okay, so then this last one is it's undefined. So an undefined slope is a graph of a vertical line. And it has an undefined slope. So for example, I'm going to use my highlighter on this one. If I have, oh, it's not working. Why aren't you working? Oh, there it goes. Okay, so if I've got a vertical line in here, and I've got my little person, just like I've had on the other ones, and this time instead of going up or down or straight across, we're falling. And he's yelling out words that are undefined. So we have an undefined slope here, okay? So think about it again in terms of change in y over change in x. So let's just say I put on here these 2 points. And I say, what's that vertical change between those 2 points? And it looks like it's 3. 1, 2, 3. And then I say, what's the horizontal change between those 2 points? And it's nothing, it's 0. And that is why it's undefined, because can you have a 0 in the denominator? No, you cannot. So this is undefined. And so that is why your slope of a vertical line is undefined. So we are getting ready to calculate our slope lots of different ways. And first we're gonna calculate our slope from two ordered pairs. And so we're gonna use our method of y1 minus y2 over x1 minus x2, or it can be y2 minus y1 over x2 minus x1, or oftentimes you see me write it as change in y over change in x. So pick one of those formulas. Then you're going to choose a coordinate pair to be your x1, y1. Then let the other coordinate pair be your x2, y2. Then use the formula to calculate your slope. All right, so we are determining the slope of the line between the following points. So I'm going to do change in y over change in x. You could also just name the points. You could say, well, I want this one to be my x1, y1, this one to be my x2, y2. And so for me, I'm going to do y1 minus y2 all over x1 minus x2. So that's going to be the route I go. So I'm going to go 3 minus negative 4, 3 minus a negative 4, all over 5 minus 0. So then I'm going to end up getting 3 plus 4 over 5, which is going to equal 7/5. So that's my slope. So what that means, fast forward into a day or two, and we're going to be doing graphing linear equations. And so I would tell you to go and graph these points. Go and graph 0, negative 4, or 5, 3. And then use your slope to graph additional points. So it'd go up 7, right 5, up 7, right 5, up 7, right 5. And we'd graph some more points that way. I'm going to hop over to question number 4, and we're going to try this one. So change in y over change in x. So if I go this way, change in y is going to be negative 1 minus 8 all over 4 minus 4. And that's going to give me negative 9 over 0. So pause right now and try to remember, which line is it? Vertical or horizontal that has negative 9 over 0, that has a 0 in the denominator? And I'm hoping that you're saying vertical, right? So it's that guy that's yelling undefined words because this situation in math is undefined. And so that's what we're going to write. So the slope for these is undefined. That's a slope. Now I want you to go one extra step for our horizontal and vertical lines, and I want you to write the equation for these lines as well. And we haven't talked about this yet, so I'm just going to throw this in as some extra information because it's coming, and I want you to start doing it now. So when we know it's a vertical line, we know that 100% of the time our equation for that line is going to be x equals c, x equals some constant. Well, how do we figure out this constant? Well, go look at your ordered pairs right now. We've got an ordered pair of 4, negative 1 and 4, 8. What number repeats and in what position is it in? So I'm hoping you say, so again, I said what number repeats and what position is it in? So the number that repeats is 4. We've got 4 and 4, and what position is it in? Is it in the x position or the y position? It's in the x position. So the number that is going to be repeated that we put into our formula for the equation of the line is going to be x equals 4. And that is the equation of our line. Because again, if we drew like a little postage stamp graph and you said, okay, let's graph these points real fast. Okay, 1, 2, 3, 4, negative 1, and then 4, 8 would be about up here. And then connect a line between those points. It would look like that. And so it's at a vertical line at x equals 4. So that should have hit at my hash mark, by the way. So that means 100% of the time, if I go here, my x is 4. If I go here, my x is 4. If I connect right there, my x is 4. So 100% of the time, x is 4. And that's why that's my equation. All right, let's try number 2. So change in y over change in x, we're going to get negative 5 minus 5. So I'm going this way. And then I'm going to get 2 minus 1. So then I get negative 10 over 1, which is negative 10. So my slope for that one is negative 10. Let's try number 3. Number 3, we've got change in y over change in x. This time for kicks and giggles, I'm going to come the other way. Change in y over change in x. I'm hoping that you're realizing too that if I go from left to right for my y's, I also have to go from left to right for my x's. If I go the other way, if I go from right to left, then I'm going to have to go from right to left for my x's as well. So you have to stay in the same order. All right, so we're going to have 1 minus 1 in the numerator, and then I'm going to have negative 3 minus a negative 4 in the denominator. So I'm going to get 0 over negative 3 here plus 4 is going to give me 1, and that's going to give me 0. Which type of line gives me a slope of 0? So just pointing this out, this again is our slope, and it gives us a horizontal line. So if x's always start with x equals something, what do you think a horizontal line starts with? It starts with y equals some constant term. Well, now what value repeats and in what position in our ordered pairs? The value that repeated was 1. So our equation for a horizontal line with our slope of 0 that goes through these 2 points is going to be y equals 1. And that is our equation of our line for that horizontal line. And again, you can think about like having to graph that too, right? Like if you did your postage stamp graph and you had negative 4 over here, so 1, 2, 3, 4, you had negative 4, positive 1, and then we had negative 3, positive 1, and then we graphed that. So 100% of the time, no matter what, where I put my pencil on this line, the y's would always equal 1 because they're always at that point because it's at 1. So that's our equation. So what I would like for you to do, I would like for you guys to do 5 and 6. 5 and 6, once you figure it out, should be m equals negative 5/3. And then 6, you should be getting m, your slope is undefined. And then I also want you to tell me what the equation is. So I'm not going to give it to you. I would like for you to tell me what the equation is going to be for this line. And then I'm going to go ahead and note that on my paper. All right, so on the next page, we are finding slope from a graph. So for the first page, we found slope from ordered pairs, and now we're going to find slope from a graph. So we are going to use instead the formula of rise over run. And be sure to show your work by drawing triangles to indicate the rise over the run between 2 ordered pairs on each of the graphs. So what we're going to do is we need to find some good lattice points that are graph crosses. And so for example, on mine, it looks like 210. So the ordered pair of 210 is a good crossing point right here. And then sometimes I have to look a little bit more and say, do I see another spot where it crosses pretty well and it's consistent? So I kind of look at some and I go down 3, left 1. It looks like there's one there. And if it crosses really well there should be another one at another down 3, left 1. And it does. It crosses pretty good there and here. And so you can pick any 2 of those ordered pairs. The simplest one would be to go like this, right? So my rise is going to be 3. My run is 1. And again, if you're doing rise over run, we're going up 3. Right 1, is it positive or negative? Are we going up and to the right or are we going down and to the right? And we're positive, so it's going to be a slope of 3 for that one. I've had students before ask me, well, instead of drawing my triangle this way, could I also draw my triangle that way, going above it? Of course. Yeah, of course you can. So that's just like the other side of the rectangle, right? So yes, you can go up and to the right. The other question I get is, well, could I go from like this point here and go all the way over here? Sure. Yeah, you could do that too. But instead, your rise would be 6 over 2, and then you would reduce it to 3 over 1, which is 3. So yes, the answer to that is yes as well. All right, so I'm going to look to the graph on the right of where I'm at. And I see a good crossing point here, and I'm just going to go over here. So it looks like I could go up to, right to. So slope is going to be up to, right to, which is still going to equal 1, which means I'm going up 1, right 1, up 1, right 1, up 1, right 1 for that. So that's going to be my slope for that one. So slope equals 1. And let's try this one now on the left. So our third example, it looks like we've got a good crossing point at the y-intercept. And then maybe another one right here. So then I'm going down to right 5. And then I might want to verify that and say, okay, can I go the other direction? Can I go up to left 5? Yeah, it looks like I can. So that means my slope for this one, it is negative because I'm going down and to the right. It's going to be down to right 5 for that one for your slope. So this is 2, this is 5, or you could do 2 and 5 like that. All right, let's look at our one on the right. So I'm going to go ahead and put like an ordered pair at 2, 5, and then maybe another one at 2, 3. And if I'm doing change in my y's over change in my x's between those points, the change in my y's, the vertical change between those 2 points happens to be 2. And the change in my x's between those 2 points happens to be 0. So my slope for this one is undefined. So for the undefined slopes and also slope of 0, I would also like you to write your equation. So the equation for this one, look at, so we know for sure because it's vertical, it's going to be x equals some constant term, right? So x equals something. What constant term are the x's at 100% of the time on that line? So what are your x's at for every single ordered pair on that? So like this one is 2, 3. This one is 2, 5. This one is 2, 10. It's 2. So x equals 2. So there's your equation, and here's your slope for that one. So what I would like for you guys to do for these two, I want you to finish these two. As you see, this is a horizontal line, so I would also like you to do the equation for that one too. So you need to do the slope, and you need to do the equation for this one. This one, you're just going to need to do the slope for here. All right, so we are going to look at another page here. And it says finding the slope from an equation. So far we have found a slope from 2 ordered pairs. We have found a slope from a graph, and now we're going to find a slope from our equation. So we are going to use the formula y equals mx plus b. This is called your slope-intercept form, which is right here. Slope-intercept form of a linear equation, where this, the m, gives you your slope, and the b is your y-intercept of your graph. So what that means is, let's say we had like y equals, I don't know, like negative 4x plus 2. What that means is that our slope of that line would be down 4, right 1, down 4, right 1, down 4, right 1. And then our y-intercept on that graph would be at 0, 2. So if we were going to graph it, it's really helpful. We can actually graph it from that equation, and we could say 0, 2, and then I'm going to go down 4, 1, 2, 3, 4, right 1. Down 1, 2, 3, 4, right 1. And I'd graph my points, and then I'd draw my line through there. And so that's why that form is helpful. So in our steps to find our slope from slope-intercept form, though, first we need to convert your formula into slope-intercept form, and then you need to identify the slope from the formula. We're also going to go ahead and identify the y-intercept from the formula and write the y-intercept in ordered pair form. So we're going to write it as an ordered pair because that's what it is. It's an ordered pair. All right, so first step, first question. We need to first convert this into slope-intercept form. So how do we get this equation into this form? So I want you to think about that. How are we going to get this equation that we're given into this form? Well, I would just work on it. I would work on like moving your x's over, and then how are we going to get x all by itself? Or not x, I'm sorry, y. How are we going to get y all by itself? So let's first move 7x over to the right-hand side. So right now what I've got is 4y equals negative 7x plus 16. Because again, I'm following the format of putting my x's first and then my constant term at the end. And now what I would like to do is divide everything by 4 because I need y all by itself. And I'm going to get y equals negative 7/4 x plus 4. And that's my slope-intercept form. So what's my slope? My slope is just the coefficient of my x. So don't put x in there. The slope is going to be negative 7/4. And then the y-intercept as an ordered pair is going to be 0, 4 for that one. All right, let's look at number 4. So let's subtract the 5x over. Or we're going to have 2y equals negative 5x minus 8. And now we're going to divide everything by 2. And so now we're going to have y equals negative 5/2 x minus 4 for that one. So what's our slope? Negative 5/2. And our y-intercept is going to be at 0, negative 4 for those. Let's try, let's try number 6. So number 6, let's subtract the 4x over. So now we've got 9y equals negative 4x minus 9. Divide everything by 9. And we're going to get y equals negative 4/9x minus 1. So there's our equation. And our slope is going to be negative 4/9. And our y-intercept as an ordered pair is going to be 0, negative 1. Okay, I am going to stop there. And I would like for you all to do 2, 3, and 5. So I want you guys to finish those up. 3 should take you like 2 seconds to finish doing that one because it's already in slope-intercept form. So you just have to fill in the pieces. And then that's it. Thanks for tuning in for this topic.